Like most things in algebra, there are more than one way that I can come up with approximations. In the last video, we showed how to find limits of a function using approximations from a graph. And now we're going to figure out how to find approximations of a limit that we cannot calculate directly using algebraic methods. So the problem that we want to calculate the limit for is the limit as x approaches 2 of x squared minus 4 over x minus 2. If we actually put the 2 into the function, I would get 2 squared, which is 4. 4 minus 4 is 0. And then 2 minus 2 is 0, which gives me 0 over 0, which is undefined. So if I actually put a 2 into the function, we're undefined. So I cannot tell you what the value is at 2, but I can tell you what value it approaches as I get closer and closer to 2. So what we're going to do is we're going to use a calculator, and we're going to make successive approximations as I get distances away from 2. For example, if I start out at 1.9 and put 1.9 into my function, I'll get a value. Then we'll try 1.99 and 1.999. And then on the other side, we will try 2.1, 2.01, and 2.001. And we will put those values into the function, and we will come up with a series that's hopefully getting closer and closer to an individual number that we will be able to find the limit. So if I put 1.9 into the calculator and square it, get 1.9 squared, which is 3.61. 3.61 minus 4 is negative 0.39. And 1.9 minus 2 is minus 0.1. And negative 0.39 divided by negative 0.1 is 3.9. If I put 1.99 into the calculator and square it, or negative 1.99 in the calculator and square it, I get 3.9601, and then I subtract 4 from it. That is negative 0.0399. 1.99 minus 2 is negative 0.01. Negative 0.0399 divided by negative 0.01 is positive 3.99. Put a 1.999 into the top of the function. Square that and subtract 4. In the numerator, I'm going to get negative 0.00399. In the denominator, I get negative 0.001. And I get 3.999. So if I was just looking from the left-hand side, it looks like my values are getting successively closer and closer and closer to 4. But we saw from the graph, sometimes I approach two different numbers. We had a graph that had an asymptote where I approached positive infinity from one side and negative infinity from the other side. Well, we also had functions where we approached one number from the left and a different number from the right, so we have to check it from the right also. If I take 2.1 squared minus 4, we get 0.41. And 2.1 minus 2 is 0.1. And my answer is 4.1. And we're going to swap those really quick. We're going to make this the 2.1, which is 0.41 over 0.1, which is 4.1. 2.01 squared minus 4 is 0.0401. 2.01 minus 2 is 0.01, which is going to give me 4.01. 2.001 squared minus 4 is 0.004. 001. 2.001 minus 2 is 0.001, which gives us 4.001. And notice as I get closer and closer to 2 from the right, I am also approaching 4. So we can make the conjecture that the limit as x approaches 2 of x squared minus 4 over x minus 2 is the value 4. Later on in this chapter, we'll learn other algebraic methods that we can calculate the limit of functions like this without having to fill out a data table.